if it's high enough volume.
Right. You mentioned quality issues, and one could be on the some documentation that FDA requires, things could be pulled out. Do you see a need for electronic document type of workflow that goes within checks automatically? And that's an opportunity for us as well, or not?
Yeah, there's actually a whole category of software called electronic batch record, EBR, which is just for the life sciences industry. And it's got a whole set of functionality to make sure you're in compliance with good manufacturing practices interpreted by the FDA.
That's one of the models, that German company that we're passing around.
That's why I asked about.
Yeah, that's pretty kind of
Very, very focused.
been there, done that.
Well, but you have the first class quality module and tying that electronic format to what we do.
Those have to be probably FDA approved, do they not?
You have to validate them, which is almost as bad as FDA approval, but it's an internal process.
Well, it's up to somebody said it's a 2-year process.
Yeah, possibly.
Validate a system like that.
This is a fun war story. I'm not sure if everybody knows it. Bill, this might be a good story to share with people if they ask, how does pull scheduling work? This is a graph that shows actual inventory, that's this blue line, for one of their flow paths. This was, I think, the first high volume flow path. And they put in pull scheduling with a target of 26,000 kilos. Actual inventory was around 37,000 kilos, so they had more inventory than they needed. So the first operation had a red light saying, don't send anything more on this flow path. So gradually, the plant consumed that inventory. Inventory dropped below the target, and the light turned green, saying to the first operation, send some more batches in. And they sent enough in to get the inventory over the target. The light turned red again, and they had very tight control. Every time the plant needed more work, the flow path needed more work, they'd send more in. After running this way for about 2 months, Glenn threw us a curveball, and he said, turn it off. I want to see what happens. I want to prove to everybody in the plant that it was the software that gave us the tight control on inventory and not an accident. So we turned it off, and they went back to the MRP way of releasing work into the plant, which was based on these padded lead times. And inventory went right back up to 38,000, 40,000 kilos within a couple of weeks. It's exactly what you'd expect. So that convinced everyone that they now had a system they could get any level of inventory and cycle time they wanted to aim for. So they did some analysis with our help, and they set a new conduit target around 18,000 kilos, put it back in place, the light was red, until inventory dropped below that target, the light turned green again, and now they had tight control over that 18,000 kilo level.
What was the pull scheduling implemented in for that Garden City? Because that's totally different than what we did for Intel.
No,
I mean, concept is the same, but
it's very similar.
what was it implemented?
The first version of this was an Excel spreadsheet,
Okay.
and you clicked a button that said refresh data, and it would go across the LAN to the data warehouse and retrieve a list of all the processes, all the batches that were in process. In fact, I think I may have a screenshot.
Got a couple coming up.
I got a screenshot. So the first version was Excel tied to MRP through this data warehouse, and the second version we just published the user interface on their intranet. But identical to what Intel used. And much better than what we had at Alcoa, which was running on VAX. So this is a screenshot of what the Excel spreadsheet looked like. Basically, there was a button you pressed on the screenshot, and it would go across the network, talk to the BPIC system, and it would calculate how many kilos were actually in process as of that morning, because there was a batch update, and compare that actual kilos to what the conduit target was for that flow path, which we disguised the names of in the spreadsheet. And the difference, with a certain projection of how often they were going to decide how much to release into the flow path, that's what all that math is about, is how many kilos to weigh up right now. If I weigh up exactly that amount, the light will turn red because the flow path will have, or the loop will have exactly that right amount. So very simple for them to use. And this literally was a little start that turned green if you needed more work, and it said turn to stop if you didn't need more work.
So how did they figure out which, when we talked about sequencing, how did they figure out which order to weigh up next?
Good leading question. For each of the paths, they go to this. This is our inbox for pull scheduling. This is a list of all of the orders waiting to be released into that path. And they would sequence this using rules, very similar to our rules engine today. In their case, I think the main way they did it is with Slack. That's what this column is, weeks ahead. So the order with the least slack would be the first order on the list. And the list would be sorted from the least slack to the most slack.
This is combination make to stock, make to order?
Right. Right. Some of the flow paths were exclusively make to stock. Some of the flow paths were exclusively make to order. Some of them were a combination of make to stock and make to order. So the orders themselves, whether it was a make to stock batch or a make to order batch, it had an order number associated with it. If it was a make to order batch, it could be pegged to a customer order, and you could drill down and see who the customer was for that order. If it was a make to stock batch, you didn't have a customer order you could peg it to, etc. So this just says I needed 1,600 kilos. If I start these 4 batches, I will get my 1,600 kilos. Send in just these 4, and you'll turn the light red because you'll have sent in enough inventory.
So they were able to use kilos. We talked about units versus hours, right? In this case, it's easy because weight normalizes all products.
Yeah,
Pretty
hours
much.
would have been better for them, but
Well, it's not like you have a unit of, you're not making an airplane and a, can opener, one unit. I mean, a kilo of one drug and a kilo of another are pretty similar probably.
yeah. But it wasn't perfect because sometimes their bottleneck would be a compression machine, and sometimes that compression machine would run product A at a certain kilos per hour and product B at a much different kilos per hour. And if you're adding kilos, you're adding apples and oranges.
Right.
So hours would have been better. They chose to do it this way, knowing they could always make it better in the future. This was easier to explain. Glenn was a really huge fan of make it simple so my people can understand it with a 5-minute class, and then they don't have to keep asking you how it works. And there's a lot of truth to that, particularly on the execution side.
Did they look at anything besides Kanban as an alternative to Conwhip? I mean, you've done Conwhip at Alcoa, right? Is that why they picked Conwhip, or did they look at Polka, or
They didn't look at Polka.
Drum Buffer Road?
They did look at Drum Buffer Road. What we implemented was really Drum Buffer Road. To me, Conwhip and Drum Buffer Road are the same, but Conwhip is more general. Because you don't have to run Conwhip through to the constraint. You do have to run Drum Buffer Road through the constraint. And frankly, generic electronic Kanban is identical to Conwhip. They're just different words that describe the same thing. So in their case, they didn't look at Polka. They did look at Kanban. They didn't look at electronic Kanban. So this is kind of a trip down memory lane. This is how the data got to their software that we sold to them. The barcode scanners were on the floor, and they would track each movement of material. That got populated real time into their MRP system, which is BPIX running on an AS400. Once a day, data was passed from the AS400 into a SQL Server data warehouse, SQL Server database. It was a data warehouse. We were using ODBC drivers and a daily batch job with Microsoft's data transformation services, exactly the same technology we used at Intel. Once it was in the data warehouse, the web server could retrieve that data and display the results in any of the web pages, and whether it was on a laptop, a desktop, or projected, like we're doing here. Let me show you some screens. Oh, I can't show you screens. At this point in the presentation, I toggled over and I started running the software on my own laptop. I'm sorry. I would have liked to show you the screens. That's
What
not
did
What did they buy? Cycle time information system was first. And it looks very similar to the run chart and the bar chart we have today. After they cut their cycle times in half and they were meeting their demand, Glenn came to me and said, "You did such a good job fixing that pain. Now my biggest pain is on customer service." And he said, Merck, which is my big